If you look at this first page, it has solving systems by graphing. The only difference between this page and page 2 is that they are in different forms. So the first page is in slope-intercept form and the second page is in standard form. So if it's in slope-intercept form, you're ready to go ahead and graph. Remember, the plus or minus over here is your y-intercept, so it tells you where to start. So you're always going to start at these numbers. And you are going to start on the y-axis. When I say start, you actually need to put a point there. So for the first line, you're going to start at 4, which means you're going to put a point at 4. The slope for this particular line is 1 over 7. Remember, that means a positive 1 over a positive 7 or a negative 1 over a negative 7. So you can go from this point, you can go up 1 and right 7, or you can go down 1 and left 7, but it'll give you the same exact slope of 1/7 for either of those points. This is not an inequality, so you're not going to dash this, you're not going to shade this. This is just graphing the line. So once you get your points, you're just going to connect those dots with a line. And some of you want to do them really short, but you want to go all the way across because these are specifically seeing where these two lines cross. And if you just do a little short one, you may never see where they cross when you go to draw your second line. For the second line, we are going to start at -3. So we're going to go down again on the y-axis, -3. My slope here is -6/7. So that's a -6 over a positive 7 or a positive 6 over a -7. Again, either one is correct. I will say that if you go down 6 and right 7, you may not see where they cross. And so if you go one direction and you think it's not going to help you figure out exactly where those two lines cross, you may want to go the other direction, or if it just walks you a little bit, you may want to keep walking. And so for this one, I would probably go up 6 and then left 7, and you'll see that they're going to cross right there at that point. And so if it doesn't cross when you do it, you may want to just walk that slope, keep walking points up until you see exactly where they cross. Because the answer here is going to be where these two lines cross. And you need to give it to me in XY form. So you need to go back and figure out where the lines cross. This particular one's at -7, +3. And that's going to be your answer for this question. The next set is not in slope-intercept form, and so we want to get it in slope-intercept form, which means we want the y by itself. To get the y by itself, we take the x and we move it to the other side of the equation. So now I have the 8y by itself on this side of the equation. And on the other side, my positive x now becomes a negative x, and that is still a -8. And then my final step here is to divide everything by the number that is in front of my y. And so I'm going to end up with the y by itself. There's a 1 in front of my x, so -1 over 8 is my slope, and 8 divided by 8 is just a 1. And so that is that equation, and I'm going to graph it just like I did the other one. I'm going to start at that -1. I'm going to go down 1 and right 8, or I could go up 1 and left 8. Either one is fine. And I'm going to connect those dots. Once I've graphed that line, I'm ready to move on to the next line. And for the next line, I need to do it again. I need to get it in slope-intercept form. So I'm going to take that 3x and move it to the other side of the equation. I still have a -4y on the left-hand side. Because the 3x moved over, it's going to be a negative 3x, and that is a plus 32. And then I am going to divide everything by negative 4. And so I'm going to divide each piece of this by negative 4, which is going to give me the y by itself. My slope is negative 3 over negative 4, which is positive 3/4 x. And then positive 32 over negative 4 is negative 8. And so once again, I'm going to graph this line. I'm going to start at that negative 8. My slope is positive 3 over 4. So I'm going to go either up 3 and right 4 or down, but down would take me off. So I'm going to walk up. So up 3 and right 4 is going to put me right here. And you can see that I have not crossed my line yet. So you can choose to start now at this point and go up 3 more and right 4. And you'll see exactly where they cross if you keep walking up that slope. So that's what I mean by walking up the slope. If you keep walking up that slope, you will eventually see where they cross exactly. And once you get where they cross, that will be your answer for this particular equation. So the answer here is 8, negative 2. So my answer for this one is 8, negative 2. For substitution, there are 3 different types you could see. The first type is that you have one of your equations already solved for a variable, and you could go ahead and plug it in. The next type is they're both solved to the same variable, and you can set them equal to each other. And then the third one is no variables are solved, and you need to make it look like that first type before you can do it. So for the first one, number 9 here, I already have this y all by itself. It is equal to negative 5x plus 10. I am going to take that and I'm going to plug it in for the y in the other equation. So I'm going to take that second equation, negative 7x minus 7y, but instead of writing y, I am going to write what y equals from the other equation. And then I'm going to finish this equation, negative 7x minus 7y equals negative 14. So that is substituting. I have substituted that whole group into the second equation, and now I'm ready to solve. So leave the negative 7x alone. Distribute the negative 7 into this group. Negative 7 times negative 5x is positive 35x. Negative 7 times positive 10 is negative 70. And then I have that equal to negative 14. You will combine your like terms. Negative 7 and positive 35. Going to give you 28x minus the 70 equals the negative 14. You need to move the 70 over. Remember, when it's going to the other side, it changes signs. It was minus 70, it's a plus. And then my final step here is to divide both sides by that 28. So I get that x equals 2. So I know the x value of my 2. I need the y value. To find the y value, you can go back to the equation where y was already by itself, and you can solve. So I can take y equals negative 5x plus 10, and I can plug in what I now know x is. Y equals negative 5 times 2 plus 10. Y equals negative 10 plus 10. What is y?
0.
Y is 0. And that is my answer to this systems of equations. So number 13 has y equals, right? And so we definitely have variables that are by itself. We have two equations with variables by itself, and they're equal to the same variable. So in this case, we actually just take the two groups and set those groups equal to each other. You can think of it as substituting in the y over here. You're going to take just the 6x minus 15 and set that equal to the 4x minus 11. And then just solve. Variables on one side of the equation, numbers on the other. So I'm going to move my variables over. Remember, if I'm moving it over, it changes signs. So 6x minus 4x gives me the 2x. And then I need to move the numbers to the other side. So this is a negative 15. So to move it, I'm going to add the 15 to both sides. Negative 11 and positive 15 gives me 4. And then I'm ready to divide both sides. X equals 2. So once and again, I have the x value. I need the y value, which is not necessarily always the case. You could solve for y first. It doesn't matter. But whichever one you solve for, you need to plug it in. So choose either equation. If I just did that top equation, y equals 6x minus 15, I'm going to plug in that 2. 6 times 2 minus 15. Y equals 12 minus 15. So y is negative 3. Number 17 has none of the variables already solved for. So I'm going to look at all of these variables and decide which one is the easiest to get by itself. And I think this y is going to be the easiest to get by itself. So I'm going to do that by moving this x over, this x group over. So that leaves me with y. My negative 2x is going to change signs when I move it to the other side. It'll be a positive 2x and minus 15. And now it just looks like the first one we did. I'm going to take this entire group and I'm going to substitute it into the second group there, or the other group. So I'm going to rewrite the second equation, 4x plus 8, and instead of y, I'm going to write 2x minus 15, and that is equal to negative 20. And I'm going to solve. Leave this 4x alone. Distribute the 8. 8 times 2x is 16x. I have a positive 8 and a negative 15. So negative 120. And that equals negative 20. All right, so my next step here will be to combine those like terms. My 4x and my 16x give me 20x minus 120 equals negative 20. Move that 120 to the other side. It will become positive. So I have 20x equals 100. And then I am going to divide both sides by that 20. So what is x here? 100 divided by 20, x is 5. Once I have my x, I can plug it right back into this equation that I had set up. Y equals 2x minus 15. Y equals 2 times 5 minus 15. Y equals 10 minus 15. So y here is negative 5. That is my answer for that. Again, there are multiple ways elimination can be set up. The first way is look, number 21, where if you look at it, you automatically see that you have variables that will cancel if you add. Number 23, we don't have variables that will automatically cancel, but you can just multiply one of those equations by one number, and you can get them to cancel. And then something like number 29, where really you don't have any that will just nicely multiply one, so you're going to have to multiply both of them. And so these are the different types of eliminations that you will have. For the first one, you are ready to go ahead and add. So remember, elimination is also called solving by addition because you just add the two equations straight down. Positive 1x and negative 1x will cancel. Negative 2y and negative 1y will give you negative 3y. And positive 18 and positive 12 will give you positive 30. And then once you do this, you are ready to go ahead and solve by division. If I divide both sides by negative 3, my y equals negative 10. So I have solved for my y value, and now I need my x value. Make sure you pay attention to which one you solve for, because you're going to go back to one of those equations and plug that number in. So if I look at the first equation, x minus 2y equals 18, I want to make sure I plug in that value of y. X minus 2 times negative 10 equals 18. X plus 20 equals 18. Subtract 20 from both sides, x equals negative 2. And so my answer for this one here is negative 2, negative 10. Of the variables will automatically cancel on 23 if I just add. But one's very, very close. You'll see that y is a negative 2y and a negative 2y. But what happens if I add negative 2 and negative 2? I get negative 4, right? So I do need to multiply one of those by negative 1, right? To get it to be the right way to eliminate. It doesn't matter which one. You can take that top or the bottom and multiply by negative 1. So if I multiply this top one by negative 1, I get positive 4x, positive 2y, and negative 14. And so then if I add, make sure you add the new row that you created. If I add 4x and 2x, I will get 6x. If I add positive 2y and negative 2y, I will get those canceled. And negative 14 and positive 14 give me 0. Divide both sides by 6. What is 0 divided by 6? What is 0 divided by anything? Yeah, it's 0. So my x value here is 0. And this is where I always go back to my original equations because I've potentially made them larger. If I were to plug it back into that negative 4x, I would do that one. It doesn't matter though with this one because I just multiplied by 1. But make sure that when you plug them back in, you plug it back into the correct variable. This was 0 for x, so 2 times 0 minus 2 times y equals 14. I basically have 0 minus 2y equals 14, which is just negative 2y. Divide both sides, y equals negative 7. So my answer here is 0, negative 7. So for this one, I'm going to do the easiest one. If I look at the x's, I have 3 and 2. And if I look at the y's, I have 5 and 8. Which one of those has the smallest least common multiple? I know that's... Yeah, the x's. I would much rather get 6x here than to get 40y, right? That's going to give me much larger numbers. So I want one of them to be positive and one to be negative. What's also nice here is I already have a positive and negative, so I don't have to worry about making it that way. So what am I going to multiply this top equation by then? I'm going to multiply that one by 2. And what am I going to multiply the bottom equation by? 3. And so I'm going to distribute to every piece. 2 times negative 3x is going to give me negative 6x. 2 times negative 5y will give me negative 10y, and 2 times 23 will give me 46. Then I'm going to do the same thing with this bottom equation. 3 times 2x, 3 times 8y, and 3 times negative 20. Now that I have a positive and a negative of the same coefficient, I am ready to just add down. Negative 6 and positive 6 cancel. Negative 10 and positive 24 will give me a positive 14. And negative 60 and positive 46 will give me a negative 14. Once I have just a variable and a number, I'm ready to divide. If I divide both sides by 14, what is my y value here? Negative 14 divided by positive 14. Negative 1. And so then I'm going to take that negative 1 to either one of these original equations, and I'm going to solve. So I have 2x plus 8y equals negative 20. Plugging in that negative 1 for y, make sure it's the right one. 8 times negative 1 equals negative 20. 2x minus 8 equals negative 20. If I add that 8 over, then I will get negative 20 plus 8 is going to give me a negative 12. And then I'm ready to divide. X equals negative 6. And so I have my final answer as negative 6, negative 1. These are the three possibilities for elimination. You could just be ready to add. You might need to multiply one equation. You might need to multiply both equations. The first type of word problem will be either a plane or a boat. It will either going with the current or against the current for the boat, with the wind or against the wind for the plane. These are always going to be set up the same. So if you look at this, a plane traveled 435 miles each way to San Salvador and back. The trip there was with the wind. It took 3 hours. The trip back was into the wind. It took 5 hours. Find the speed of the plane in still air and the speed of the wind. Just so you know, the less time is going to go with where it's helping you, the plus. The more time is going to go where it's hurting you, the minus. Like that's how these are going to be set up right now. As you get into higher math, they may give you different distances, so then it might potentially change. But these will always be this way. So the trip there was 3 hours. That's my time. With the wind, that means the plane and the wind were working together. And it was 435 miles. Against the wind was 5 hours. So that means the wind was working against the plane. I am always going to divide out this number that's in front. I'm always going to divide that out, so that I end up with just the P plus W here. And I'm going to divide the 435. And then I'm going to have the P minus the W. And I'm going to divide there. Now I'm actually ready to do what I just did on the other page, eliminate. I'm going to add down. My W's will eliminate and I will have 2 times P. Over here, I'm just going to add these two. And so add them up. You don't have to multiply by anything in these particular ones. They're just going to be perfectly ready to eliminate. And then once you eliminate that wind, you will be solving for the plane by dividing by 2. 232 divided by 2 is 116. What did that tell me? What does 160 stand for? Yeah, the miles per hour, the speed of the plane. Once I know the speed of the plane, I can go back and plug that in. 116 plus the wind should equal 145. Just subtract. Subtract that 116 over. And you should get that your wind was 29 miles per hour. So you will have a word problem where it is obvious that there are two things happening. In this case, the school is selling tickets. On the first day, 9 senior citizen tickets and 4 students sold for $102. On the second day, $120 was made by selling 9 senior citizen and 10 student tickets. What are the two things that are clearly obvious that we don't know? Right, the price of the 2 tickets, right? So if X is my price for my senior citizen and Y is my price for my student, then that is going to help me set up my 2 equations. My first one says 9 senior citizen, 4 student equals 102. So 9x plus 4y equals 102. My second sentence says $120 was made with 9 senior citizen and 10 student. 9x plus 10y equals 120. I am not quite ready to eliminate, right? What do I need to do? Multiply 1 by -1. So if I multiply this top one by -1, that's going to be a -9x, a -4y, a -102. Now I am ready to add. So once I've eliminated and divided, I have solved for y equals 3. What does that tell me? Y equals 3 tells me what? $3 for which one? Student ticket, right? Y. And then I'm going to go back to one of my equations. It doesn't matter which one. And I am going to solve for the price of the senior citizen ticket. So I'm going to get x equals 10, which tells me my senior citizen ticket is $10. So graphing the lines is exactly the same. The only thing you have to decide here is whether it's solid or dashed. So number 41 is in slope-intercept form. Number 45 is in standard form. Slope-intercept form is very simple. I'm going to start at that 2. My slope here is 1 up 1 over 1. So you're just doing your slope like you did before. Go up 1 over 1, put a point, and graph. This one is solid. It is solid because this has an or equal to. I'm going to do the same thing with the second line. I'm going to start, well, hopefully at the right. Let's move him up where he goes. +2. There we go. Start at 6. And I am going to go up 5 and right 1 or down 5 and left 1. In this case, I'm going to choose to go down 5 and left 1 because up 5 takes me off my graph. That is also a solid line. Now here's the thing. Before, and you can do it both ways. Some of you are going to want to go ahead and graph him and decide the shading. Some of you are going to want to shade first. So I'm going to shade first. For this line right here, this top line, is that above or below? Is y bigger than the line or smaller than the line? Bigger. So that's actually going to be bigger than the line. For the blue line here, is the blue line, is the y smaller or larger? What does it show you? Smaller. So it's a little hard sometimes to tell when it's a really steep slope like this. So I always go to that intercept. Is this side of the line smaller or is this side of the line smaller? Which one? Yeah, the right side, so to speak, is the one that's smaller, even though sometimes you can't tell that it's going to be right or left. But in this case, it's really more of a right side of that line. So below the line is actually represented over here. And so my answer is where they cross. And you may not be able to tell where they cross until you graph both of them. So if I had graphed this one down here, then this would have been where they crossed. So you just have to be careful that you graph it accordingly. For standard form, you do want to put it in slope-intercept form first. So I do want to move my x over. I have negative 5y is greater than or equal to now negative x plus 30. Here's the thing. I do have to potentially flip my greater than less than. In this case, I will. I am dividing everything by negative 5. When I divide an inequality by a negative, it switches my sign. So I now have my y by itself, but instead of greater than or equal to, I need to switch that sign. And then I have the negative 1 over negative 5, which gives me my slope. Positive 30 over negative 5 gives me where I start. So I'm going to start at negative 6. I'm going to go up 1 and right 5. And this is also going to be a solid. What would make it a dashed? None of these are dashed. What would make it a dashed? If it did not have the or equal to piece. All right, this line's really easy to see where I'm going to shade. Since I flipped that sign from greater than to less than because of this particular slope, it's easy to see that I am going to be shading down here with this one. And let's do the second one. All right, once again, you want to move that 6x group over. When you move it over, it is going to change signs. So I have negative 5y is less than or equal to negative 6x plus 5. And then once again, we are dividing everything by negative 5. I have the y. Again, this is going to flip because I divided by a negative. My slope is negative over negative, so it is positive 6 over 5. Positive 5 over negative 5 is a negative 1. And so I'm going to start at negative 1. I'm going to go either up 6 and right 5 or down 6 and left 5. Both of those work. This is also solid. But now, am I shading above or below this line? Above or below this line based on my final answer here? Above the line. So in this case, above the line is actually over here. So if I'm shading above this line, I'm shading right here. And there's only one tiny little piece where they cross, which is right there. So the part where they cross is, trying to make it darker so y'all can see it. This is where they cross, right there.